Morning, everybody. I'm sorry to not be with you today, but I am at a virtual conference. I guess I would be up in Williamsburg, but I'm sitting in my office. We're going to review Trig from yesterday and then go on to inverse trig. So you're going to want to take notes as we go along. You do have a pair deck. So if you're in the pair deck, you can take these notes and have two screens going on, or you can take notes on paper. It doesn't matter to me how you do it. But I did want to review some trig first. So I'm going to zoom in a little bit, see if we can see these a little bit better. Remember SOHCAHTOA. So the very first thing you want to do is identify what sides you have and what sides you want. So you can figure out which trig function to use. We're going to go opposite the 42 is the opposite side. Opposite the right angle is the hypotenuse. We don't have an A, so we can't use cosine and we can't use tangent. All we have is an O and an H, so we have to use sine. So sine of 42 equals, remember this is a fraction, O over H, so X over 25. You can make this into a proportion to make it a little easier to look at. You're just going to multiply those diagonals, right? So we've got X equals 25 times the sine of 42. So you come over to your Desmo calculator. Oh, before I do anything else, make sure it's in degree mode. If you've just opened it, it will be in radians. So you want to make sure you do that. 25 times the sine of 42. And I literally just put it in the calculator the same way I see it here. So that's going to be X equals 16.73. Let's look at example 2. Example 2, we're going to do the exact same thing. SOHCAHTOA and TOA. Feel free to pause me at any time so you can try it yourself. We're going to start at that angle. Sometimes in those super acute triangles, it's hard to figure out where to start. Start at the angle. Opposite, hypotenuse, adjacent. I don't have a hypotenuse in this triangle, so I can't use sine and I can't use cosine. I have to use tangent. I have the O and I have the A. So we're going to do tangent of the angle, tangent of 75 equals O over A. So the first letter is always your numerator, and the second letter is always your denominator. Red flag should go off in your head right now because we've got an X in the denominator. So remember, tangent of 75 is just a decimal. When you put it into the calculator, it's going to give you a decimal. So X times tangent of 75 equals 12. If this said 75, X equals 12, we would divide by the 75, right? We're all good with that. So we're just putting a tangent in the front. It's still just a one-step equation. It just looks a little fancy. The tangent 75 crosses out, and over here in my calculator, I can do 12 divided by tangent 75 and get my answer. 3.12 makes me a little crazy too, but if I think about it, 3.12 makes perfect sense because if this angle is 75, this angle is going to be super skinny. It's going to be 15. So my smallest side is opposite my smallest angle. That makes a lot of sense to me. I'm going to come over here, just going to go around clockwise and do number 4 before number 3. Start at the angle, label the O. Got the other leg, so hopefully we're getting pretty good at saying that's the A. So we're going to use tangent of 53. If I don't remember, that's TOA, so it's opposite over hypotenuse, opposite over adjacent, opposite over adjacent. We can put in our little 1 to make it a proportion, make it easier to look at. I'm going to cross multiply there. So X equals 7 times the tangent of 53. 7 tangent 53. 9.289. So 9.29. And I can think about that right there. That 53 is going to be bigger than this other angle, which would be 37. So it makes perfect sense. The medium side is across from the medium angle. Come over to our last one. Ask yourself, what do I need to mark? Where do I start? What do I need to mark? So if I start at the 36, I don't have an opposite, right? So I'm thinking cosine already. Got my hypotenuse, got my adjacent. So that confirms cosine 36. 36. Always cosine of the angle. And ca is adjacent over hypotenuse. Hypotenuse always sinks to the bottom. So hypotenuse always in the denominator. A over h, so 19 over x. I've got an x in the denominator again, so I'm going to make it over 1. Cross multiply, so 19 equals x times, that was supposed to be a cosine, 36. So I'm going to divide by cosine of 36 and divide by cosine of 36. Those cross out. And I'm just going to come over to my calculator. It's still in degree mode because I haven't closed it. As soon as you close it, that's when you need to put it back in degree mode. So 19 divided by cosine of 36. Anytime the x is in the denominator, you're going to have the x in the denominator, or the cosine in the denominator over here. So 23.48, 23.49, 23.49. So what I have done for you here is I've given you a way to self-check this. Some of my answers are going to go away, but we still have that 16. If you click on this yellow bubble, you'll be able to check your answers. You won't know which answers go where because they're lowest on the top and largest on the bottom. They're in ascending order, but we can check that we've got the 16.73, so we know we did it right. Okay, so you can check your answers through this entire document. On page 2 or slide 2, there's a video. This is Miss Kimbrough's video with several examples. So if you're still not sure what to do after you do slide 3 and slide 4, come back here and watch her video, okay? Maybe she'll say something in a way that I don't say it. For inverse trig, we're still going to use sine, cosine, and tangent, but we're going to do inverse. So here, the difference is we're looking for an angle. I'm going to zoom in again. I'm looking for that angle x, right? So because I'm looking for an angle, we're going to start the exact same way. We're going to go opposite and hypotenuse and adjacent. So ca and toa. I don't have a hypotenuse. There's no information there. So I can't use sine and I can't use cosine. I'm going to have to use tangent. When I start writing this, though, I don't have an angle to write. So you see that little tiny degree symbol up there? Instead of putting a degree symbol, we're going to put a -1. Anytime you're looking for degrees, you've got to use inverse tangent, inverse sine, inverse cosine. That little -1 is kind of taking the place of the degree symbol, but everything else stays the same. Opposite over adjacent, 9 over 20, and that equals x. So instead of putting your angle next to the tangent, you're putting your ratio next to the tangent and you're finding your angle. So I'm going to come over here, my Desmos. I'm going to show you what that looks like over here. I've been typing in the trig functions so far, but over here, you've got all of these trig functions. When you get into legit trig next year with Algebra 2 trig and math analysis calculus, you'll use all of these, but we're going to kind of live in these 6 right here. Sine, cosine, tangent, and then inverse sine, inverse cosine, inverse tangent. We're going to click on that inverse tangent. It's going to give us our -1, so we don't have to worry about it. And then 9 over 20. You don't even need that parenthesis. It's pretty smart. So 24.2. 24.2 degrees. Now, with degrees, it's a little bit harder to figure out reasonableness, but 24 degrees is going to be less than 45, less than half. So this is going to be the small side, small angle, which kind of makes a little bit of sense. Let's come look over at the 17 and the 32. So again, you're going to label everything the same way you would. Start at your angle, even though you don't know it. You've got the opposite, you've got the hypotenuse, you've got the adjacent. We have nothing on the O, so we're going to use A and H. That's cosine, cosine -1, A over H. That's the ca, right? So cosine -1, inverse cosine, A over H. Remember that 32, the hypotenuse always sinks down to the bottom. Then we're going to come over here and do functions. We're looking for an angle, so we need that -1. Cosine 17 divided by 32 is 57.9. 57.9 degrees. And it kind of makes sense that this is the biggest angle because, the 17 is pretty small. So again, a little bit harder to think about reasonableness here, but those two acute angles do equal 90 degrees. So a lot of times that helps a little bit. So I'm going to pause here for a minute. I want you to pause me. Try to label your O, A, and H and decide whether you're going to use inverse sine, inverse cosine, or inverse tangent. So hopefully you paused me and you went across from the angle, and that's the O, and you can recognize the H pretty easily. So ka and toa. Hopefully you guys are all ahead of me and you figured out its sign. We don't have the adjacent, so we can't use one of those. So we're going to use sine inverse and then O over H, 21 over 28. And come over here and do sine. I can type it in. 21 over 28. 48.6. That 9 is going to round the 5 up. So 48.6. This is almost 45 degrees. So this is almost an isosceles triangle, just not quite. Last one. Start off exactly the same. Identify the O, identify the H or A. We don't have an H. So it's got to be tangent. I'm looking for the angle, so I've got to put that little -1 to hold that degree symbol because I don't have an angle. I'm looking for it. And then TOA is O over A, so 13 over 18. We come over here and go to my functions again. Tangent of -1 and then 13 over 18. 35.8. 35.8 degrees. Okay. Oh, I guess I need to get my clicker, my pointer tool. Click out of that. And you have your answer choices here too. So 24.2 and 35.8. We've got all our answers there. Okay. What I want to see is your work on the pear deck. Okay. Just having the answers is not going to be enough. So as you go through the rest of this, you've got 2 questions on slide 4. You've got the answers underneath the cute little right triangle, guys. So please do your work and then go check it. Do your work and go check. Do your work and go check. All 6 of these are going to be inverse trig. You're just looking for the angle. You're just looking for the angle. You're just looking for the angle, right? All these 3 are inverse trig. You're going to do exactly what we just did. Slide number 7 is going to just give you a little Cliff Notes version. So if you have 2 sides, and I'm looking for a side, we're going to use Pythagorean theorem. Have 2 sides, looking for a side, use Pythagorean theorem. If you've got 2 sides and you're looking for an angle, you're going to do inverse trig. That's what we were just doing. So you have 2 sides and you're looking for an angle, you want to do inverse trig. So inverse trig is the only one that goes with angles. And then if you have a side and an angle, you have a side and an angle, and you're looking for another side, that's when you use trig. So all right triangles, all 3 different ways to find things, you're given 2 pieces of information and you're looking for a 3rd piece of information. Okay, looking for 2 pieces of, or have 2 pieces of information, looking for a 3rd. Here you're going to do the same thing. So you're given a side, you want a side, you're given an angle. You're given a side, you're given an angle, you want a side. These all look like trig to me. Your answers are under here. So if you pull this little bubble aside, you will see your 4 answer choices. You just need to do the math to figure out which one goes where. Here you're looking for an angle, looking for an angle, looking for an angle, looking for an angle. So these are all going to be inverse trig. So even though the directions say they're all mixed up, slide 8 is all trig and slide 9 is all inverse trig. Okay, good luck, guys, and I will see you on Friday.